Hey, welcome. Today we're going to dig into something fascinating, the huge leap from an AI that can just chat to one that can actually act. So, how does an AI go from simply talking to you to proactively solving problems all by itself? Well, let's dive in and find out. So, you've probably messed around with an AI, right? They can draft an email for you, answer a trivia question, maybe even tell a cheesy joke. But that's all just conversation. What does it really take for an AI to stop just responding to you and start acting? To actually go out and achieve a goal on its own? That's the big jump we're going to explore. And this slide really breaks it down for us. You see, on the left, you've got your simple chatbot. It's totally reactive. You ask something, it answers. End of story. But on the right, that's the AI agent. It's proactive. It doesn't just wait for a prompt, it actually plans, it reasons, and it uses tools to hit a complex goal. This right here is the world of agentic AI. Okay, so how in the world do these agents actually work? Well, first, we've got to look under the hood at the engine that's powering them. This is the absolute breakthrough that finally allowed AI to really understand the nuance of human language and, most importantly, context. So, before 2017, the main game in town was something called recurrent neural networks, or RNNs. And they had this one huge bottleneck. They had to process language one word at a time, in a line. This made them super slow and, even worse, kind of forgetful. They'd get to the end of a long sentence and basically forget what the beginning was about. But then, in 2017, this groundbreaking paper dropped, introducing the transformer, and it changed literally everything. The secret sauce inside the transformer is this incredible mechanism called self-attention. Now, instead of going word by word, self-attention lets the model look at all the words in a sentence at the exact same time. It weighs the importance of every single word against every other word. And in a flash, it builds this super rich map of context and relationships. It's like it can see the whole picture at once. Okay, let's make this real with an example. Take the sentence, "The robot was tired because it worked all day." An older RNN might actually get confused about what it is referring to. But with self-attention, the model instantly, and I mean instantly, sees the powerful link between it and robot, no matter how far apart they are in the sentence. That ability to see the forest and the trees is the key. And this table from that original paper shows us exactly why it's so much faster. Look at the sequential operations column. A recurrent layer needs more and more steps the longer the sentence gets. That's what that O of n means. But a self-attention layer, it just needs one, O of 1. What that really means is you can throw a ton of modern computing power at it all at once. It's massively parallel, which makes it unbelievably efficient to train. So we've got this incredibly powerful engine, right? But raw power by itself isn't enough. I mean, you can have a Formula One engine, but without a car around it, it's not going anywhere. To build something useful, you need a blueprint. And that's exactly where agentic design patterns come in. They give us the structure we need to turn all that understanding into intelligent action. And this quote from the book on agentic design patterns just nails it. You have to harness the power of these cognitive engines with structure and thoughtful design. These patterns are basically reusable, proven solutions that help developers build agents that are robust and reliable. Let's look at a couple of the big ones to see what I mean. First up, and you could argue this is the most important one, is tool use. This is what gives an agent its hands and feet in the digital world. It's the ability to stop just talking and start actually interacting with other systems. So here's the gist of how it works. You give the agent access to tools, which are really just other programs like a weather API or a company's database. Then, when you ask, "Hey, what's the weather like in London?" the agent's brain, the LLM, realizes, "Aha, I need my weather tool for this." It figures out it needs to send the city London. And then this orchestration layer, think of it like a dispatcher, makes the actual call. The weather data comes back, and the LLM formats it into a nice, clean answer for you. This is how an AI actually does things. But, what happens when the agent's first try isn't quite perfect? That's where our second pattern, reflection, comes into play. This is all about giving the agent the ability to look at its own work, criticize it, and then make it better. And this quote really gets to the heart of it with that phrase, iterative improvement. It's not about just taking one shot and hoping for the best. With reflection, the agent can get into a cycle of refinement. It doesn't just do the work, it improves the work. So let's just trace the loop on this diagram here. Step 1. the agent generates some kind of output, maybe a chunk of code or a paragraph of text. Step 2, it, or maybe another specialized critic agent, looks at that output and evaluates it. It asks itself, did this code handle all the tricky edge cases? Is this paragraph factually correct? Then, in step 3, it takes that critique and uses it to refine the output and try again. And this loop can just keep going until the work is up to snuff. All right, so now it's time to put it all together. We've got the breakthrough engine that can really understand context, and we've got the blueprints that give structure to its actions. This synthesis, this combination, is what creates the incredibly powerful AI agents we're starting to see today. And really, this is the core idea of this whole explainer, boiled down to a simple formula. You take the raw contextual power of the transformer engine. You channel it through smart agentic blueprints like tool use and reflection, and what you get on the other side is no longer just text, it's intelligent action. So let's just quickly recap the big takeaways, shall we? First, the transformer architecture with self-attention at its core is the powerful engine that unlocked true contextual understanding. Second, agentic design patterns are the essential blueprints that shape all that power into reliable, useful actions. And finally, patterns like tool use and reflection are what give these agents the power to actually interact with the world and get better over time. You know, we're at such a fascinating point in time. We have the engine, we're developing the first real blueprints for building truly intelligent systems. So the question that's left for all of us isn't just what we're going to build next, but how all of these new creations are going to reshape our world. Thanks for tuning in.